Hello dear students, welcome to the course of Engineering Thermodynamics. Myself Mihir Misri, Assistant Professor from Mechanical Department of LJ Institute of Engineering and Technology. So today we are going to continue our session on vapor power cycle, and in particular today we are going to discuss about Rankine cycle. Okay, so we will see one example on Rankine cycle. So let us read the data given on the screen first, and then we will try to write down the given data. So as per the given data on the screen, in a Rankine cycle, the steam at inlet to the turbine is saturated at pressure of 35. Here you can see I have highlighted the word saturated. That is the reason, because at the inlet of the turbine your condition of the steam is saturated, and the pressure is 35 bar and exhaust pressure is 0.2 bar. That is, from the outlet of the turbine the steam is having pressure of 0.2 bar. Now determine the pump work, turbine work and Rankine cycle efficiency and quality of the steam at the end of expansion. Assume mass flow rate of 9.5 kg per second. Okay, so now we will write down the given data first. So as you can see on the left hand side of the section, P1, that is pressure at the inlet of the turbine, we will consider as point number 1. So P1 is given as 35 bar. You can convert this 35 bar into kilopascal, that is equivalent to 3500 kilopascal. Further, the next pressure given is at the exhaust of the turbine. So we will consider that at point number 2. Right, so exhaust of the turbine is P2, so P2 pressure is given as 0.2 bar. If you will convert into kilopascal, that will be 20 kilopascal. It is easy to understand. Remember, the conversion is 1 bar is equal to 10 raised to 5 pascal. Okay, further we are given the mass flow rate, that is 9.5 kg per second. So m dot here is equal to 9.5 kg per second. Now the things that we are supposed to find out is, the very first thing is pump work, so that is WP, then turbine work, that is WT, then Rankine cycle efficiency, that is eta, right, and quality of the steam at the exhaust of the turbine or at the end of the expansion process. So you know that the expansion process will end at the exit of the turbine. So we are supposed to find out the dryness fraction at point number 2. Because we have denoted point number 2 as the exhaust of the turbine. So we are supposed to find out X2. Okay, so these are the things that we are supposed to find out. So remember students, for every numerical there is a single one approach, that is identify what you are supposed to find out. And you should be aware about the equation of that particular thing. Okay, so as of now here you can see that pump work, turbine work, then X2, that is dryness fraction at outlet of turbine, and eta. All equations should be known to you guys. So as you can see, the pump work equation would be what, or turbine work equation would be what, you should know. Okay, but first of all, before doing so, we will plot the TS diagram, okay, for the given problem. So for finding out or drawing the TS diagram, you should know the condition of the steam at the inlet of the turbine. So as you can see, the condition of the steam at the inlet of the turbine is already written by saturated word. Here they have only written a single word, that is saturated. The meaning of saturated is what? It is dry steam. Okay, so if it is dry steam, then you have to plot that particular point on saturated vapor line, and saturated vapor line is on the right hand side of the saturation dome. Okay, so as you can see on the screen, I have plotted the TS diagram, and in the TS diagram you can see I have mentioned the 1 number point on the saturated vapor line. So remember students, the word saturated, the significance of that word is here, that you will plot the 1 number on the saturated vapor line, that is the right hand side of the saturation curve. Clear? So that is the TS diagram. Now from 1 point you know that 1 to 2, that will take as isentropic expansion. So isentropic expansion means entropy will remain constant. So 1 to 2 will be straight vertical line towards the downward side. So obviously the 2 point will be somewhere in the wet region. Then 2 to 3, that is what 2 to 3 is constant pressure heat rejection process. So constant pressure heat rejection process, right? And also here phase will change, so temperature will also remain constant. So you can see 2 to 3 process is drawn by horizontal line, straight line on the TS diagram, and 3 point will be obviously the pure liquid point or saturated liquid point. See, remember, during 2 to 3 in the turbine or in the power plant, during 2 to 3, which device will be used? During 2 to 3, condenser will be used, because from the exit of the turbine, the steam will be supplied to the condenser. And what is the function of the condenser? Function of the condenser is to convert the steam into liquid. That is why here also steam is converted into liquid. So you can appreciate that the whole thing is taking place or identified using the process 2 to 3 in the TS diagram. Okay, so at the point, clear, point number 3 is plotted on the saturated liquid line. Okay, so now from 3 to 4, which device you will be using? So you should know 3 to 4 we will use pump. So what is the function of pump? Function of pump is to increase the pressure from condenser pressure to the boiler pressure for the water, right? So here during 3 to 4 you will supply the pump. Okay, so 3 to 4 process is drawn over here in the TS diagram. From 4 to 1, what we will do? From 4 to 1 you will use boiler, right? So boiler is what boiler is doing? Boiler is increasing the temperature of the water to the saturation level, and then it is converting the saturation liquid into saturation water, right? So remember that point. Okay, so this is how you can plot the TS diagram. So TS diagram is important in numerical also, in order to clear the picture for the given numerical. Okay, it will be very much helpful if you draw the TS diagram. Okay, so we have plot the TS diagram. I have also mentioned the pressure, that is 35 bar and 0.2 bar. 35 bar is boiler pressure and 0.2 bar is condenser pressure. Clear everyone? Now here we are supposed to find out the pump work. So pump work, you should know that, now you know that pump is between 0.3 and 4. So what will be the equation for pump work? Obviously enthalpy difference between 0.4 and 3. That is why WP is equal to H4 minus H3. See on the screen, I have already written. Next, what we are supposed to find out? Turbine work. So turbine work, for that we have the equation, that is turbine work is H1 minus H2, because turbine is situated between point number 1 and 2, right? Clear? Next is what? Efficiency. So efficiency, you know that efficiency is equal to net work divided by heat supply. So if you observe that, so according to that, net work is equal to what? Turbine work minus pump work divided by heat supply. Now turbine work and pump work is already written over here, right? That we have already discussed in the previous discussion. So you simply substitute the value of turbine work and pump work. Now heat supply. So heat supply is taking place during the boiler, and boiler is between 4 and 1 point. So what you will do in order to find out the heat supply, you will subtract H1 minus H4. Okay, so H1 minus H4, that will be your heat supply. Okay, now logically you should think which enthalpy should be the first one in every term. Okay, in turbine work, in pump work and in heat supply, which enthalpy should be the first one? So the enthalpy which is having higher value should be the first. Okay, so you know that in boiler, at the outlet of the boiler you will have steam, and at the inlet of the boiler you will have water. So obviously steam will be having higher enthalpy compared to the water. That is why H1 will be higher compared to H4. Clear? Same way for turbine. So at the inlet of the turbine you will have hot steam, dry saturated steam. At the exhaust of the turbine you will have steam, but that steam will have less enthalpy, because at the expense of the enthalpy the turbine is rotating. Okay, if you are decreasing the enthalpy, that much energy is converted into your rotation. Okay, shaft rotation. Okay, so here in the turbine H1 will be higher than H2. Same way for the condenser. So for the condenser, you can appreciate that you are rejecting the heat from 2 to 3 point. So you are ultimately cooling down, or you are converting the steam into water. So you know that at the inlet of the condenser you will have steam at point number 2, and at the outlet of the condenser you will have at point number 3 you will have water. So H2, which is enthalpy of steam, will be higher than H3, which is enthalpy of liquid. Clear? And from 3 to 4, that is you have pump. So H4 will be higher than H3 because in the pump, what you will, if you observe or just imagine the pump at your home, okay, that is used for, just imagine the pump at your home that is used for transferring the water from the low elevation to high elevation, right? So there you know that at the outlet of the pump you will have higher enthalpy and at the inlet of the pump you will have lower enthalpy. Clear? So here also in this pump H4 will be higher than H3. Clear? So that is how the convention for signs are taken. Now we will find out. Now ultimately the thing is, in any problem of Rankine cycle, if you manage to find out H1, H2, H3 and H4, you can find out every value. That is the meaning. Okay, so now let us start by finding the H1 first. So for finding out the H1, you know that point number 1 is dry saturated point. So for dry saturated point, you know that the enthalpy of dry saturated point is what? H1 is equal to Hg. Right? Now remember student, at point number 1, the pressure is how much? So I have already told you that during whole 4 to 1 process, that is during the heat addition in boiler, your pressure will remain constant. Okay, so here the pressure is 35 bar. Okay, so keep that thing in your mind. For 4 to 1, for any point you take on the line 4 to 1, for all the points or any point on line 4 to 1, the pressure will remain same, that is 35 bar. So here also at point number 1, the pressure will be 35 bar. So if you don't know the equation H1 is equal to Hg, then you can recapitulate the lecture of steam formation diagram. Okay, it is already uploaded in the playlist. Now H1 is equal to Hg at which pressure? 35 bar. So now what you will do, you will open the steam table. Okay, in that steam table you will find out the pressure based table. Okay, you will first open the pressure based table, not temperature based table. So sir, what is pressure based table? Simple. Pressure based table means on the steam table it will be written in the bracket, that is pressure table. Okay, so you will find out that table. Okay, and also you can refer to how to read the steam table lecture also. Okay, that is already uploaded on the playlist. Now here we will do what? You will identify the 35 bar pressure. Now it might be possible that the steam table which you are using is not using the same unit of pressure, that is bar. So it might be possible the steam table you are referring might be using kilopascal unit. So you have to convert the unit of bar into kilopascal. So here the steam table which I am referring, that in that steam table the pressure is in kilopascal. So I will convert this 35 bar into kilopascal. So that will give me 3500 kilopascal. So I will identify the 3500 kilopascal and corresponding to that which value of Hg is there. So I will write down that value. Clear? I hope you can see on the screen I have written Hg at 3500 kilopascal, that is 2802.7 kilojoule per kg. Right? So that will be my enthalpy at point number 1. Simple, very easy to understand. We are supposed to find out only 4 enthalpies, student. Among that, 1 we have already found. Okay, H1 is clear. Now we want to find out H2. Now just think for 2 minutes logically. Point number 2 is in wet region, right? So if point is in wet region, then what will be the enthalpy of wet steam? Recall. So enthalpy of the wet steam will be H2 is equal to HF2 plus XHFG2. Right? You recall that, okay? Enthalpy of wet steam, I have already discussed that in previous sessions. Okay, so remember that. So according to that, you need HF2 and X and HFG2. Right? Now here students, it is interesting to know that point number 2 is at which pressure? Observe this. Observe the TS diagram. Point number 2 is at which pressure? So you see that point number 2 is 0.2 bar pressure. Is at 0.2 bar pressure. So now if it is at 0.2 bar pressure, majority of the students are making this mistake. Remember my words. Point number 2 is at 0.2 bar pressure, not at 35 bar pressure. Okay, so what you will do? You will open the steam table, and in that steam table, you will find out the value of HF2 or HF and HFG at 0.2 bar. But right now don't open the steam table because one problem is there. What is the problem? The problem is X2 we don't have. That is dryness fraction. So first we will have to find out the X2, right? So remember one thing, the X2 we have to find. So for finding out the X2, what we will do? We will use the equation for entropy. Okay, so now for finding out X2, I will use the equation for entropy. So for entropy of wet steam, the equation is same as enthalpy, that is S2 is equal to SF2 plus X2 SFG2. Now here SF2 and SFG2 can be found out at 0.2 bar pressure because SF2 and SFG2 are at 0.2 and 0.2 is having pressure of 0.2 bar. Observe the DS diagram. 0.2 is having the pressure 0.2 bar, right? Because 2 to 3 process, that whole process is taking place at constant pressure, right? So that is why 0.2 bar, that is the pressure corresponding to point number 2. Clear? So here you will find out SF2 and SFG2 at 0.2 bar, right? Our aim is to find out X2, students, right? So I should know the S2 also, right? S2 also. So now you know, observe and think logically. Process 1 to 2 is drawn straight vertical line. Now what is the significance of straight vertical line? Significance of straight vertical line is that the value of point number 1 and value of point number 2 will be same, right? You can see on the screen also, right? Point number 1 and point number 2, for both point 1 and 2, your entropy will remain same. So that means S2 and S1 will both will be same. Clear everyone? Now that means I should have the value of S1. Now what is the value of S1? Now S1, now point number 1, this is very interesting. Keep this and keep attention and keep focus that S1, point number 1 is at which pressure? Point number 1 is at 35 bar pressure. And what is the condition of steam at point number 1? Condition of steam is dry saturated steam. So now you should know the equation for entropy of dry saturated steam. So the equation for entropy of dry saturated steam is simple. S1 is equal to Sg, right? But Sg at which pressure? Sg at which pressure? Now majority of the students are making mistake at this point as they take Sg at 0.2 bar. No, wrong. We are supposed to find out Sg. Sg, that means dry saturated vapor. Dry saturated vapor. Now corresponding to that, which point is there? Point number 1 is there. And for point number 1, what pressure is given? 35 bar is given. So now that means you will find out Sg from the steam table at 35 bar, right? So if you can manage to find out 35 at 35 bar Sg value, now we will go in reverse order. Observe the right hand section, we will go on the reverse order. So if you have Sg at 35 bar, you will have S1. If you will have S1, you can have S2. If you have S2, you can find out SF2 and SFG2. SF2 and SFG2 is at 0.2 bar. So you have S2, SF2, SFG2. So you can find out X2. And using that X2, you can find out H2. Okay. Very interesting way to find out the value of H2. So let us do that. Now further, we will find out H2. So first of all, what I will do at 35 bar pressure, I will find out the value of entropy of dry steam, right? So I will find out Sg. So as you can see on the screen, the table is already given for 35 bar, that is equal to 3500 kilopascal. So the value of Sg is 6.1244 kilojoule per kg. Right, so that will be my S1. So Sg is equal to S1 is equal to 6.1244 kilojoule per kg Kelvin. Clear everyone? Okay. Now S1 and S2 will be same because it is isentropic expansion process, right? So now S2 is equal to S1, that is equal to 6.1244 kilojoule per kg Kelvin. Now further, S2 is equal to what? S2 is equal to, now point number 2 is in wet region. So for wet region, the entropy equation is what? S2 is equal to SF2 plus X2 SFG2. Now here majority of the students are making the mistake. Now find out SF2 and SFG2. So which pressure you will use? Think it. No. For finding out SF2 and SFG2, you will use the pressure 0.2 bar, not 35 bar. Don't make this mistake. Sir, why sir? Because 0.2 is at which pressure? 0.2 is at 0.2 bar pressure. Okay, so corresponding to 0.2 bar in the steam table, if you convert it in kilopascal, it will be 20 kilopascal. So at 20 kilopascal, the value of SF and SFG is given on the screen, that is 0.8320 kilojoule per kg Kelvin and 7.0752 kilojoule per kg Kelvin respectively for SF and SFG. Okay, so you will substitute the value of SF and SFG in the above equation. You have the S2 also, you can find out the X2, right? So value of X2, that is dryness fraction, is 0.748. Remember, you will not use any units for X2 because it is fraction, dryness fraction. Okay, now that is the X2, and that was also asked in the numerical to find out the condition of the steam at the end of isentropic expansion. Now remember, isentropic expansion process is the process 1 to 2 itself. So at the end of the isentropic expansion, so the isentropic expansion process is ending at point number 2, right? So corresponding to point number 2, what is the dryness fraction? That we have already found out. So your answer is there, that is X2 is equal to 0.748 is nothing but dryness fraction at the end of isentropic expansion. Clear everyone? I hope it is clear up to this point. Now we will move further. From X2, what we will do? We will find out H2. Now for H2, we will need HF2 and HFG2 and X2. X2 we already have. Now HF2 and HFG2. Now tell me at which pressure you will find out HF2 and HFG2. Just pause the video and think for a second. Obviously, for HF2 and HFG2, you will use the pressure 0.2 bar. Okay, students? Because point number 2 is located or is taking place at the pressure of 0.2 bar. Clear? So open the steam table and check the value corresponding to 0.2 bar. So here 0.2 bar is again 20 kilopascal and corresponding to 20 kilopascal. As you can see on the screen, the data is given that HF and HFG is 251.42 and 2357.5 kilojoule per kg respectively, right? So substitute these two values in the above equation, right? So if you will do so you can have the value of H2 as 2014.83 kilojoule per kg. Okay, so that is how, see, our aim is to find out H1, H2, H3, H4. Okay, don't get tired. It is a lengthy numerical, but once you are aware about the practice, if you will solve the 3-4 numericals, then it will be very easy. Okay, so understand this very carefully. So the main aim is to find out H1, H2, H3 and H4. We have found out H1 and H2, right? Now we are left with two terms, that is H3 and H4. So let us find out. Just think about point number 3. So enthalpy at point number 3. How you will find out? Think about it. Pause the video and think for 2-3 seconds. Okay. So now you can appreciate. Your answer should be, sir, point number 3 is located at saturated liquid line. Saturated liquid line means what? Pure liquid. And for pure liquid, what will be the enthalpy? Obviously, the enthalpy will be HF. Okay, so the HF3 is nothing but HF. But at what pressure? At what pressure? So corresponding to point 3, what pressure is given? 0.2 bar, right? So that means you will find HF at 0.2 bar. Clear everyone? Very easy. Open the steam table. Pardon. Very easy. Open the steam table and corresponding to 0.2 bar, find out the value of HF. That is 251.42 kilojoule per kg. Clear? Now we will move forward. So that is our H3. Now the crucial thing, last point, that is point number 4. Now you can see that point number 4 is in saturated or pure liquid region. Okay, is in pure liquid region. So if it is in pure liquid region, so for that, how can you find out the value of enthalpy? So for that, you will use this equation that is written on the screen. H4 minus H3 is equal to VF3 P4 minus P3. Sir, how this equation is arrived? Refer the lecture of Rankine cycle efficiency. Okay. So now, according to this equation, you should have the value of H3, VF3, P4 and P3. Now, we have the value of H3 already, right? We have the value of P4 and P3. Sir, how do you have the value of P4 and P3? Now see students, I have already told you, process 4 to 1, whole process is taking place at constant pressure. That means what? That means whatever pressure you have at point number 4, same pressure will be there at point number 1. Right? So P1 and P4 are same. Right? So P1 and P4 are same. That means P4 is equal to 35 bar or 3500 kilopascal. And P3, so P3 and P2 will be same. So that means P2 and P3 are same. So P3 is having how much value? 0.2 bar. Right? Clear? So P4 and P3 we already have. Now what is VF3, sir? So VF3 is nothing but the value of specific volume of saturated liquid at point number 3. Now point number 3. So corresponding to point number 3, what is the pressure? Again, the pressure is 0.2 bar. So for 0.2 bar pressure, find out the value of VF. Because, sir, why VF? Because point number 3 is on saturated liquid line. Right? So if it is on saturated liquid line, so for that you will find out VF. Open the steam table, find out the pressure 0.2 bar and corresponding to 0.2 bar, find out the value of VF. So it will be 0.001017 meter cube per kg. So what does it signify? So what is the meaning of this thing? Simple, student. If you take 1 kg of water at 0.2 bar, then that water will occupy this much volume. Okay, 0.001017 meter cube of volume. Okay, clear? Okay, now that is VF3. We have the value of VF3. Substitute in the above equation. So now for finding out H4, substitute the value. So H4 minus. Now remember, student, one more thing over here, that you have to keep all the units in system international SI unit. So that means you have to convert kilojoule into joule and kilopascal into pascal or bar into pascal. Clear? Why, sir? Because VF3, observe the unit of VF3. VF3 is in meter cube per kg. That is pure SI unit. That is why you have to convert all units into SI, system international. Okay. So here H3 is 251.42 into 10 raised to power 3. Don't forget to write into 10 raised to power 3. Otherwise your answer will become wrong. Okay, that is equal to VF3. VF3 is equal to 0.001017 into P4 minus P3. P4 is how much? 35 bar and P3 is how much? 0.2 bar. Convert bar into pascal. So into 10 raised to 5. I have written common. Okay, 10 raised to 5 is common. So now you rearrange this sum and try to solve and find out H4. So value of H4 will be 254.959 kilojoule per kg. Clear? So now, student, that means observe the all highlighted terms. So all highlighted terms are H1, H2, H3 and H4. We have all 4 enthalpies, right? So if we have all 4 enthalpies, then we can find out pump work, turbine work and efficiency. So pump work is equal to what? H4 minus H3. Substitute the value. The pump work will be 3.539 kilojoule per kg. Then turbine work. What is the value of turbine work? H1 minus H2. Substitute the value. So you will have the final answer of turbine work as 787.87 kilojoule per kg. Now remember, students, observe here, compare the pump work with turbine work. So the value of pump work is 3 kilojoule, around 3.5 kilojoule. And value of turbine work is nearly around 800 kilojoule. So you have drastic difference between pump work and turbine work. Okay, so keep this thing in your mind. Okay, now we are supposed to find out efficiency. So for efficiency, you already know the equation written on the left hand section, right? So efficiency, substitute all the values, so we can find out the efficiency as 30.78%. Okay, so that is the final value of efficiency. Okay, thank you.